the first case of the Poisson distribution, it has been determined that out of 2,000 patients, 0.1% suffer from the side effects of the drugs administered. Use the Poisson distribution to determine the probability that first part, 4 patients suffer from the side effects, second part, less than 2 encounter the effects of the drugs, and the third part, between 5 and 7 suffer from the effects of the drugs. So when you are told to use the Poisson distribution, the first thing you have to do is to derive the Poisson distribution. Just write the general formula of the Poisson distribution, isn't it? So you know very well that the exponential 0 is equals to 1. So 1 defines the whole range of a probability measure, isn't it? Since the mean of a Poisson distribution is given by lambda, then it will imply exponential lambda minus lambda is equals to 1. 0 is lambda minus lambda. So if you use the laws of indices, that is exponential lambda times exponential negative lambda is equals to 1. Same base, you add the powers, you get that, isn't it? So here we have exponential negative lambda, then we expand exponential lambda, then the whole of that will give us 1. So when you expand exponential lambda in Maclaurin series, we will have exponential negative lambda. So expanding exponential lambda, you get lambda raised to power 0 over 0 factorial plus lambda raised to power 1 over 1 factorial plus lambda raised to power 2 over 2 factorial plus lambda raised to power 3 over 3 factorial plus until the end, then it is equals to 1, isn't it? Are we together? So when you take exponential negative lambda inside the bracket, we end up with lambda raised to power 0 over 0 factorial times exponential negative lambda plus lambda raised to power 1 over 1 factorial times exponential negative lambda plus lambda raised to power 2 over 2 factorial times exponential negative lambda. You continue with the same trend until you reach the last term, the last value of n, and that is supposed to give you the whole range of a probability measure, isn't it? So from there you now go to the question. You've been told it has been determined that out of 2,000 patients, meaning they are telling you that the number of patients is 2,000. 0.1% suffer from the side effects. So it means these patients which suffer from the side effects, if you denote them with P for the probability of success. So P denotes the probability that a patient suffer from side effects, isn't it? You see that? So the probability that a patient suffer from the side effect is 0.1%. And what is 0.1%? 0.1% is 0.1 divided by 100. 0.00? 1. That is 0.1%. Are we together? Yes. 0.1% is 0.01. So it means this is the probability that the patient suffer from 1%. Then you'll be told to use Poisson distribution, meaning the moment you are looking for lambda, lambda is opposed to the mean. The lambda is, because lambda is approximating the binomial distribution, isn't it? And the mean of the binomial distribution is NP, and that is the lambda, isn't it? Are we together? Lambda is the mean, and the mean of a binomial distribution is n times p. So what is n times p to give you the mean? N times p, 2,000 times 0.001. What have you found? 2. You found 2. So are you seeing the reason why you are using a Poisson distribution? Because the mean of a binomial distribution was less than 5. Are you seeing that? Yes. So we are saying when the mean of a binomial distribution is less than 5, then we approximate it with the Poisson distribution. Have you seen how that has come about? The mean of the binomial distribution must be less than 5. And you can see 2 is less than 5. So we are using the Poisson distribution lambda, isn't it? So it means anywhere you see lambda, you put 2. Are we together? So we found the value of lambda to be 2. Having found the value of lambda, we now get the probabilities. Are we together? Let us now start by getting the probabilities. Remember, we've not reached a point where we are going to the question, but these ones are irrelevant. I was just using to explain. There are steps you already know. You don't need to repeat them here, isn't it? I'm the one repeating them for the explanation purposes, isn't it? Are we together? Good. So you found lambda is equals to lambda is equals to 2. So let us now go to the probability. So start with the probability that there is no outcome. No outcome means zero outcome, isn't it? So no outcome is what? When there is no outcome, it means lambda is raised to power 0 over 0, and everything is times exponential negative lambda, isn't it? Times exponential negative lambda. Then when we have exactly one outcome, when you have exactly one outcome, it means the power of lambda is 1, isn't it? So exactly one outcome we have lambda raised to power 1 over 1 factorial. Then it is times exponential negative lambda. You saw the exponential negative lambda was the factor outside the bracket, was multiplying everything, isn't it? Are we together? Then you move exactly to two outcomes. What do you have? Lambda raised to power 2 over 2 factorial exponential negative lambda. Remember, the question is guiding. You can see less than 2, 4 question suffers from the side effects between 5 and 7. So when they talk about between 5 and 7, meaning we need to go up to exactly 7 to be able to answer this last question. So the question is what is guiding you to some point where you should reach, isn't it? Meaning we need this 7, so we need lambda raised to power 7, isn't it? Are we together? So we continue with the same process until we get where lambda is to power 7, because it is part of the questions we are going to answer, isn't it? Okay? So exactly 3 outcomes, continue. That is lambda raised to power 3 over 3 factorial exponential negative lambda. Exactly 4 outcomes. Lambda raised to power 4 over 4 factorial exponential negative lambda. Continue. Then the next one, exactly 5 outcomes. Lambda raised to power 5 over 5 factorial exponential negative lambda. Exactly 6 outcomes. Lambda raised to power 6 over 6 factorial exponential negative lambda. Exactly 7 outcomes. Lambda raised to power 7 over 7 factorial exponential negative lambda, because we will need that 7, so we reach there, isn't it? Are we together? So let us start by getting these values. Go to the calculator and get these values. Remember, lambda is 2. Where this lambda is 2. So I don't expect you to go to that fake calculator and do this. Remember, this is 2 raised to power 0 over 0 factorial. Then somebody will put exponential, then 0 in front of it. In that other irrelevant calculator. When you're using the right calculator, you know lambda raised to power will give you the power on top of exponential function, isn't it? But this other calculator will not put it on top of exponential function, meaning you have to raise it to power 0. If you put 0 in front of it, then you are automatically irrelevant. Are you seeing that? Because it is exponential raised to. So it is not 0 here, it is 2. So start with the substitution. Where there is lambda, you put 2. So start with the first one. Start with the first one. 2 raised to power 0 over 0 factorial exponential raised to negative 2. Where there is lambda, you put 2. Give me this value. What do you have? Raised to power 0 over 0 factorial times exponential negative 2. You have 0.1353. 1353. Then go to the next one. 2 raised to power 1 over 1 factorial exponential negative 2, because where the lambda you put 2. 0.270. 0.2707, isn't it? Are we together? Go here. 2, when lambda is 2. 2 raised to power 2 over 2 factorial exponential negative 2. You have? What do you have? 0.27? It is the same as this one.
Yes.
Meaning you are using values, you should have gone maybe to 5 decimal places. They are just there. Why are you hiding that? 27067. 06 0.27067. And this one, when lambda is 2 raised to power 3 over 3 factorial exponential negative 3, negative 2. What do you have? 0.180. 0.180. Oh. They are the same. Because this is 4 over 2 factorial is 2. And this is 2 over 1 is also 2. They are the same. Good. Move this other one. Lambda raised to power 4. 0.0902. Then this one, lambda raised to 2 raised to power 5 over factor of 5 factorial exponential negative 2. 0.0361. Are we together there? Then move to the next one. Lambda raised to power 6 over 6 factorial exponential negative lambda. 0.0? 0.0120. Move to the next one. The last lambda raised to power 7. 0.00? 0.0034. 0.0034. So we found the exact outcomes, isn't it? So let us now start answering the question. Start with the first one. 4 patients suffer from the side effects. When they say 4 patients, that means exactly 4 patients, isn't it? So what is the probability that exactly 4 patients suffers from the side effects? See, this is exactly 4 outcomes. Yes. And the outcomes, this language say those who are suffering from the side effects, isn't it? So exactly 4 is what? Are you seeing that? So the probability that exactly 4 patients suffer from the outcome is 0.0902. So you just come and you write here exactly 4, then you write the formula and the answer, isn't it? And you are done. Are we together? Then the next one, less than 2 encounter the side effects of the drug. So less than 2, what does that mean? Less than 2. Less than 2 means what? Either 0 or 1 you don't reach 2, isn't it? Yes. Are you seeing that? Are we together? So this is less than 2, either 0 or, and 0 outcomes means no outcome. So the probability of no outcome, what have you found? So it is lambda raised to power 0 over 0 factorial exponential negative lambda, or means plus, isn't it? Then 1 outcome means lambda raised to power over 1 factorial exponential negative lambda, and all these values you found there. Are you seeing that? Are we together? That is less than 2 means 0 or 1, and 0 outcome is this, or is addition, 1 is that, isn't it? So if you substitute those values, what do you get? For 0 outcome, you found to be 0.1353, isn't it? Then or is the plus, 1 outcome, exactly 1 outcome you found to be 2707. And what is that probability of less than 2? 0.4? 0.6? Are we together? So this is the probability of less than 2 encountered the side effects. Then answer the last one. The last one is this Roman 3, isn't it? Between 5 and 7 suffer from the side effects. So between 5 and 7 meaning either 5 or 6 or 7, isn't it? See, that is between 5 and 7. Are we together? Either 5 or 6 or 7. When they don't say, when when you are dealing with probabilities, when you hear the word between, without the term exclusive, then it is always inclusive. Are you seeing that? So when they say between 5 and 7 out from the side effects, between 5 and 7 in bracket exclusive, meaning you exclude 5 and 7. When they don't use that term exclusive, it means the whole of that range is considered. Are we together? Is that okay? So between 5 and 7 out from the side effect means either 5 or 6 or 7, because those are the values between 5 and 7. Is that okay? So either 5 or 6 or 7. So what is that? 5 suffer from the side effects is exactly 5 days, isn't it? 6 suffers from the side effects is exactly this, isn't it? 7 suffers from the side effects is exactly this, isn't it? So between 5 and 7 is either this or this or this, and or implies addition, isn't it? Are we together? Is that okay? So between 5 and 7 suffers from the side effects is either 5 outcome or 6 outcome or 7 outcomes. So exactly 5 outcomes you found was lambda raised to power 5 over 5 factorial exponential negative lambda, or is addition, isn't it? Exactly 6 outcomes you found to be lambda raised to power 6 over 6 factorial exponential negative lambda, or exactly 7 outcomes you found to be lambda raised to power 7 over 7 factorial exponential negative lambda. So can you now substitute those values? This value here, you found that probability here, you found this probability here, you found that probability. So if you add those 3 probabilities, what do you get? 0.05 115. So that is the probability that between 5 and 7 suffer from the side effects of the drugs. We found it is 0.0515.